What is an AI product? Artificial intelligence has rapidly evolved from a research curiosity into a cornerstone of modern software and hardware innovation. Yet as the ecosystem expands, it becomes increasingly important to distinguish between a foundation model and a true AI product. While many companies have rushed to market with thin wrappers around large language models, LLMs, only some have succeeded in transforming AI into products that solve meaningful problems, integrate proprietary knowledge, and create lasting value. This essay explores what constitutes a genuine AI product, why simply exposing a model through an interface is not enough, and what design principles define next-generation AI-driven solutions. 1. Foundation models as products. Foundation models themselves, such as GPT, Claude, or Gemini, can rightly be considered products. They are sold through APIs, subscriptions, and cloud platforms, and they deliver broad utility to developers, businesses, and end users. These models serve as general-purpose reasoning and communication engines, capable of processing language, images, and even multimodal input. However, by themselves, foundation models are not sufficient to create specialized products for most users. They are platforms more than complete solutions. Just as cloud infrastructure became the substrate on which entire ecosystems were built, foundation models provide the raw intelligence layer for new AI products. 2. The weakness of wraparound apps. In the early stages of AI commercialization, many startups and even established companies launched products that were little more than thin wrappers around foundation models. These apps often added a minimal user interface, branded themselves as AI-powered, and offered generic functions like summarizing emails, scheduling meetings, or generating text. The problem with this approach is twofold. 1. Low differentiation. If anyone can wrap the same API, then competition becomes a race to the bottom on pricing and design. 2. Shallow value. Simply exposing a model's generic capability rarely solves domain-specific problems in ways that businesses or individuals find indispensable. As a result, many such Me Too apps struggled to find product-market fit. A calendar assistant that can be reproduced by anyone with an API key is not a durable product. 3. What makes a good AI product? A genuine AI product must go beyond being a thin veneer over a model. Several characteristics define strong offerings. A. Integration of proprietary data. The strongest AI products do not rely only on the model's training set. Instead, they integrate unique data sources, whether proprietary documents, customer histories, sensor outputs, or enterprise databases. Proprietary data creates a moat, ensuring the product delivers value that a competitor cannot simply replicate with the same foundation model. B. Domain knowledge and context. Every industry, medicine, law, finance, logistics, has layers of domain-specific rules, practices, and constraints. Good AI products embed this domain expertise into their logic. They may use expert systems, curated ontologies, or fine-tuned submodels to align AI reasoning with real-world practice. C. Composite architectures. An AI product is rarely just one LLM call. Instead, it integrates multiple computational elements: databases for structured information, regression models for predictions, vision models for image and video analysis, mathematical solvers for optimization, sensor systems for real-time feedback, rule engines for compliance and safety. Together, these create a system of intelligence in which the LLM acts as the communication and orchestration layer. D. Human-centered design. At its core, an AI product must serve people. This means interfaces, workflows, and outcomes must be designed around human utility, not model capabilities. The best AI products make complex technology invisible. offering users a sense of empowerment rather than cognitive overhead. 4. LLMs as communication devices. One of the most powerful insights in AI product design is that an LLM is not the product itself, but rather a communication layer. Just as graphical user interfaces made computers accessible in the 1980s, LLMs make interaction with data, systems, and algorithms more natural today. Through natural language, an LLM can translate user requests into structured queries against databases, interpret results from math solvers or simulations, explain sensor data in everyday language, orchestrate workflows across multiple subsystems. In this framing, the LLM becomes the translator and conductor, while the true functionality of the product comes from its integration of specialized components. 5. Examples of AI-enabled products. To better understand this concept, consider some examples. Healthcare diagnostics. An AI product might combine a vision model for analyzing medical images, a regression model for predicting risk factors, and an LLM to explain findings to clinicians in plain English. The proprietary data comes from patient records and clinical research, legal research tools. Instead of a simple chatbot, a robust product integrates legal databases, case law analysis engines, and citation checkers. The LLM serves as the interface, letting lawyers ask natural language questions while ensuring responses are grounded in authoritative sources. Industrial automation. An AI-enabled manufacturing system may pull data from sensors on production lines, run optimization algorithms for scheduling, and use LLMs to explain system status to managers. These examples illustrate how the product is AI-enabled rather than just AI. 6. The importance of AI-enabled, not just AI. A subtle but essential distinction is the difference between AI products and AI-enabled products. AI products are those where AI is the core value proposition. Examples include ChatGPT itself or Midjourney. AI-enabled products are those where AI enhances but does not define the product. For instance, Psychinhaladiasan and Selkerkonsent, a CRM system that integrates predictive AI to score leads, is not an AI product in itself. It is an AI-enabled business tool. In practice, most enterprise adoption is occurring through AI-enabled products, since organizations prefer to extend familiar workflows rather than replace them wholesale. 7. The role of proprietary data as a moat. One of the greatest strategic lessons for AI product builders is that proprietary data forms the defensible moat. Anyone can access a large model, but only a healthcare provider has its patient outcomes, only a law firm has its case notes, and only a logistics company has its delivery network patterns. By combining foundation models with such exclusive data sets, companies can create products that are not easily commoditized. This is where long-term value lies. 8. Beyond utility apps toward significance. The critique of many early AI apps was that they were little more than utility layers, email summarizers, calendar assistants, note takers. While these have value, they are not transformative. A good AI product tackles deeper challenges, accelerating scientific discovery, enhancing decision-making in high-stakes environments, unlocking new creative possibilities, optimizing complex supply chains. These are problems where AI shifts the order of magnitude of what is possible, rather than shaving minutes off a routine task. 9. Building blocks for next-generation AI products. From the principles discussed, the next wave of successful AI products will likely share several building blocks. First, foundation model access. A general reasoning engine as a core. 2. Specialized components, vision, math, regression, or rule-based systems. Third, proprietary data, unique datasets that lock in differentiation. Fourth orchestration layer, APIs and pipelines that link everything together. 5. User experience layer. Simple, intuitive interfaces powered by LLMs. Together, these enable AI systems to act not as isolated tools, but as holistic solutions. Conclusion. An AI product is far more than a chatbot or a wrapper around a large language model. It is a complete solution that integrates AI as an enabling technology within a broader system of data, models, tools, and user experience. Foundation models are essential, but by themselves, they are insufficient. The most enduring AI products will be those that embed proprietary data, harness domain expertise, integrate multiple computational tools, and use LLMs as communication devices rather than the product itself. As the ecosystem matures, the distinction between AI and AI-enabled will become crucial. Those who focus only on superficial wrappers risk obsolescence, while those who build deeply integrated domain-specific and human-centered products will define the future of intelligent technology. Read my previous blogs at https://www.patreon.com/Steve Hovland. If you get value from these blogs, please consider joining my Patreon as a member at the $1, $2, or $4 level.